So let us try to understand these fundamentals. And before we start with the fundamentals, let us try to get this definition. See, this concept would only be understood if you do a lot of numericals. I'll take you through the definitions, but unless and until you do
Okay.
the numericals, this won't make any sense. So let us go through the definitions first. So at least the definition part is over. So what is a gram atomic mass or gram atom? The atomic mass of an element expressed in grams is called gram atomic mass.
Mm-hmm.
So for example, they have taken atomic mass of hydrogen to be 1.008 atomic mass unit. Now, yesterday we had discussed what is one atomic mass unit, and we had described that one atomic mass unit in terms of kgs also, if you remember.
Mm.
So, what we had said was that one atomic mass unit is quantity of mass. So, one atomic mass unit is a quantity of mass equal to 1/12 the mass, 1/12 the mass of my standard C12 atom. Any doubt till here?
No.
And then if you remember, we had spent some time to understand the relation between atomic mass unit and uh, grams or kgs. We had calculated this figure. So what we want is basically, in short, what we want is we don't want to, write figures small like this. We don't want to keep writing very small figures like this, and that is why we have replaced this with one atomic mass unit, or it is written as one unified mass now. Is it making sense?
Yeah.
Or, just to be more clear, basically what they have said is, if all this doesn't make any sense to you, all they are trying to tell you is, कि bhai, if you take a C12 atom,
Mm.
it will be exactly equal to 12 AMU. That is all that they are trying to say. Is it making sense? And now anything that you
Yeah.
take, and now anything that you take oxygen, you take hydrogen, you take a mass of a proton, you take a mass of a neutron, anything can be written in terms of this AMU. Is it making sense?
Yeah.
And then, of course, we understood the concept of fractional atomic masses also, and then we understood that why, you know, you'll have fractional atomic masses. So, for example, though the mass of carbon 12 is 12, but then the fractional atomic mass of carbon is a representative of its three flavors, and that is why it is written as 12.001. Is it making sense?
Yeah.
So, similarly, for chlorine also it is 35.5 unified mass. So for neon, it is 20.179 unified mass. Are, are all these things making sense to you?
Yeah.
And now what they are saying is that this, as this continues, more and more things will become clear. And now what they are saying is that atomic mass of an element is expressed in grams. So whatever atomic mass, if it is expressed in grams, it would be called gram atomic mass. And similarly, for molecular mass also, they have given the same definition that the molecular mass of a substance expressed in grams is called gram molecular mass. Are we clear till here?
Yeah.
So, for example, all they are saying is that if you take this carbon and instead of this unified mass, you write it as 12.001 gram.
Mm-hmm.
So,
Mm.
it will be called the gram atomic mass of carbon. That is it.
Yeah.
That is all that they are trying to say. The definitions are a bit confusing, if you ask me. I never understand this definition part.
Okay.
And the second thing that they are saying is, so if you take this, for example, you take a molecule like methane. So you have the gram atomic mass of carbon, you have gram atomic mass of hydrogen, and then you
Mm-hmm.
calculate and you will get the gram molecular mass of methane. Is it making sense?
Mm.
And then, if you remember in last lecture, we had said something like that. In covalent compounds, you will get the molecules, but in ions. you only get the ratio that when you write, when you take a ionic compound like NaCl, basically NaCl is just telling you the ratio of the sodium and the chloride ions and NaCl. Is it making sense?
Yeah.
So if you remember, we had spent some time to understand, and that is what they are writing here. So that is why they don't write it as molecular mass, they write it as formula mass. So the formula of an ionic compound does not represent one molecule, but it gives the ratio of the constituent ions. Is it making sense? And that is
Mm-hmm. Yeah.
and that is why they call it gram formula mass. Is it making sense?
Yeah.
Or if you are getting confused, just remember that CaSO4. This is just giving you the ratio of carbon is to sulfur is to oxygen. The ratio is 1 is to 1 is to 4. That is it. Because this calcium sulfate is an ionic compound, and therefore you won't have molecule of calcium sulfate. You'll have ions. Is it making sense? Am I making sense?
Mm, yeah. Yeah.
Are we clear till here?
Yeah.
So, see, there is a bit of complication here because calcium will exist as Ce2 positive and sulfate will exist as 2 negative. But just to simplify the matters, let's stop here and just understand that there is a difference between the molecular masses and the formula masses. Are we
Okay.
are we clear till here?
Yeah.
Now, of course, what I'm trying to tell you again and again is that unless you start doing the numericals, things won't make any sense. So for example, one of the solved example in they are calculating the molecular mass of glucose. So they calculated the molecular mass of glucose as 180.162 AMU. Now all they are saying is that if you write this as 180.162 grams, this will become the gram molecular mass of glucose. That is it. That is all that they are trying to say.
Okay.
Are we clear till here?
Yeah.
So gram molecular mass of sugar. So just take the figures which are given to you. Atomic mass unit can be replaced by gram, and you'll have a gram molecular mass, or you'll have a gram atomic mass. Are we clear till here?
Yeah.
So nothing. If, again, frankly, if you ask me, the definitions are more complicated. The numerical part is simple.
Mm-hmm.
And now we come to the mole concept. Mole concept is pretty simple. If you want to look at the definition says amount of substance that contains as many particles or entities as there are atoms in
Mm.
a gram of C12 isotope. Again, this C12 isotope is our base. Is our base. Everything is being compared to C12. So what they are saying is you take 12 gram of C12 isotope, and whatever be the number of atoms in this sample would be equal to 1 mole. Is it making sense?
Yeah.
Now the number of particles they have been able to calculate, what they did was they calculated the mass of one C12 atom. They found it to be, they would have done something, they used this mass spectrometer, and they were able to calculate the mass of one atom of carbon. Then what they did was
Mm-hmm.
they divided this 12 gram, because 12 gram is a standard. They divided 12 gram by the mass of one atom of C12, which is equal to 1.99264 into 10 raised to the minus 23. And the figure they got
Mm-hmm.
was this. This is equal to
Okay.
1 mole. Now, one thing that you need to understand is that mole, you know, in a certain way, mole is not you can't limit mole to chemistry only. You can take 1 mole of stars also. So, for example, I can take this much amount of stars also, and then I'll say
Mm-hmm.
I have 1 mole of stars. Or I
Okay.
can take or I can take this many number of sand particles, and I'll
Okay.
say that I have a mole of sand particles. That is it. Have you
Mm-hmm.
understood what I said?
Yeah.
So roughly, they take the value of 6.022 into 10 raised to power 23.
Mm-hmm.
Any doubt till here?
No.
And if you refer NCERT, they have a special symbol for the 6.022 into 10 raised to 23. And please remember that we'll be using this in a chapter in physics also.
Okay.
We'll be doing kinetic theory of gases. We'll be using all these concepts in that chapter. Plus,
Mm.
in chemistry also, there is a chapter of states of matter. I told you. This is chapter 1, 2, 3, 4, 5. This is chapter 5 of chemistry, class 11th. So again, this concept
Okay.
would be used there also. Are we clear till now?
Yeah.
So this today's lecture will become a base lecture. Again, we will be referring to this lecture again and again. Are we clear till here?
Yeah.
Now, to make things very easier, and here now the things become very easier because if you see mass of say 1 mole of any substance in grams is equal to the gram molecular mass, and this is where the things becomes very easier. Why do the things become easier? Because now what they are saying is that if you take 12 gram of C12 atom, it is equal to 1 mole of C12 atoms. Is it making sense?
Mm. Okay. Yeah.
Basically, basically, if you have understood, now what they are saying is that I should also write this as 6 into 10 raised to power 23 atoms. I'm just rounding off the 6.022 to 10 raised to power 23 as this. Are we clear till here?
Yeah.
So what they are saying is that if you take one mole of 1 mole of atoms, of course this would be the number of atoms, but this would be equal to the gram atomic mass of element. Are you able to link the things?
Yeah.
So for example, and the same would be true for the molecules also. So what they are saying is that for example, if you take uh, 18 gram of water, this 18 gram of water will have 1 mole of water molecules would be equal to 6 into 10 raised to the 23 molecules of water, but it will consist of 2 into 6 into 23 atoms of hydrogen plus
Yeah.
1 into 6 into 10 raised to the 23 atoms of oxygen. Is it making sense?
Yeah.
Now, what I want to, because you are in class 11, I won't discuss this with class 9, class 10 students. But what you need to
Mm.
understand is, what you need to understand is that we take the atomic mass unit of hydrogen to be 1, of oxygen to be 16. But now you understand that this would be in some decimals. Have you understood what I've said?
Yeah.
Because we would be taking, we, just to be very exact, we can take the exact atomic mass of hydrogen depending upon the three isotopes of hydrogen. So it would be in terms of some decimals. Similarly, for oxygen also, it would be in terms of the isotopes of oxygen. Is it making sense?
Yeah.
So now, if you zoom a bit, you will be able to see that in class ninth and class 10th, we were working on certain amount of certain amount of approximation. Are we clear till now?
Yeah.
Just to reiterate, I hope what I'm saying is making sense? So just to reiterate, so for example, if we take carbon, we usually write the mass of carbon to be 12 gram, but to be
Mm-hmm.
exact, it will be 12.001. Is it making sense?
Yeah.
We usually take the mass of neon to be 20, but to be exact, this would be 20.179. Is it making sense?
Yeah.
The exact mass of argon would be 39.948. We usually write this as 40. If you see your class
Mm-hmm.
9, class 10 books, you will see this. And now what I'm trying to tell you is that, the approximations which are working as that if I take argon, the
Mm.
mass would be taken as 40 gram.
Okay.
You just uh, so for example, this can be written as 39.948 atomic mass unit also can be written as
Okay.
39.948 gram or 40 gram. This would be
Mm-hmm.
equal to 40 gram per mole, would be equal to 6 into 10 raised to 23 atoms of argon. Is everything making sense now?
Yeah.
So if you see this calculation, so for example, carbon they have gone to the decimal places. Again, hydrogen they have gone to the decimal places. But usually in class 9, 10th, what we were doing is we were doing a calculation like this. Are we clear?
Mm-hmm.
All I want you to understand is the approximation that we are bringing in. That is all that I want to tell you. Are we clear about the relation between the basically what I'm trying to ask you is, are we clear now between this relation of 1 mole and the number of particles, 1 mole and gram atom of element, 1
Yeah.
mole and gram molecule of substance, 1 mole and gram formula mass of substance? So this is 1 mole. This is 1 mole of sodium. This is 1
Mm-hmm.
mole of H2O molecule. This is 1 mole of CO2 molecules. This is formula mass of NaCl. This is molar formula mass of calcium carbonate. Is it making sense or not?
Yeah.
And finally, just to add to, just give me a second, 1 second.
Yeah.
So, okay. So now we should be able to understand this table also that 1 mole of atom is these many amount of atoms. The mole number of moles of an element is the mass of an element divided by atomic mass. So what this means is that, for example, let me assume I'm taking say 36 gram of water.
Mm.
So if I want to see how many moles of water do I have, then what I write is I have 36 gram of water. I divide this by the molecular mass of water, which is 18 gram per mole, and I will have 2 moles of water. Is it making sense?
Yeah.
Yeah. So
Yeah.
we understand this also. Mass of one atom is equal to atomic mass divided by 6 into 10 raised to 23. So for example, if I want to weigh 1 gram of a water molecule, I'm sorry, if I want to weigh, I'm sorry, if I want to, if I want the mass of one molecule of water,
Mm.
then all I need to do is, because I know that 6 into 10 raised to 23 weigh 18 gram, so I just divide 18 gram by 6 into 10 raised to power 23, and I have approximately 3 into 10 raised to power minus 23 gram. This is the approximate weight of a molecule of water. Is it making sense?
Yeah.
So now I understand 1 mole of molecules. I understand this is called gram molecular mass. I understand how to find the moles and more mass of one molecule also. The same logic follows whatever we have discussed for atoms. The same logic follows for molecules also. Are we clear till here?
Yeah.
Now we come to something which is called the molar volume. Molar volume. Now for molar volume, see what I need to make you aware is that I'll be referring to this definition which is given in NCERT class 11th, NCERT class 11th chemistry chapter 5. Yeah,
Mm-hmm.
because in molar volume you'll find a lot of confusion. If you start looking at usually the private publishers, you'll find a lot of confusion. So to avoid confusion, what we should always refer is to the the fundamental source of class 11th and class 12th. So
Mm.
NCERT class 11th chemistry chapter 5 says that STP, they define STP, the standard temperature and pressure to be 0 degree Celsius, 1 bar. They define 1 bar as exactly 10 to the power 5 Pascal. And they say that the STP molar volume of an ideal gas would be equal to 22.7 liter per mole. Is it making sense?
Yeah.
I'll repeat. What they are saying is that if you take, let us say, 18 gram of uh, H2O water vapor, what they are saying is that its molar volume would be equal to 22.7 liter per mole. Is it making sense?
Yeah.
Of course, they are saying that this is an ideal gas. So we'll deal with that. But now I'll tell you the kind of confusion which is there. So this is what they are saying, that this is how they have defined the STP. And now slowly I'll reveal the confusion which is there and how do we deal with the confusion. So they say the previous standard is still often used and applies to all chemistry more than a decade old. In this
Mm-hmm.
definition, STP denotes the same temperature. The temperature is the same, but slightly higher pressure of 1 atmosphere. The old STP has been defined in terms of atmosphere, but the new STP has been defined in terms of 1 bar. Are you able to see the difference?
Yeah.
So 1 bar as per our new STP is exactly equal to 10 raised to the power 5 Pascal. But as per old STP, they used 1 atmosphere, and 1 atmosphere were equal to 101,325 pascals. Have you understood the difference?
Yeah.
So here the molar volume was 22.7 and here the molar volume is 22.4 liter. Have you understood the logic?
Mm. Yeah.
Have you understood the logic? So, you know,
Yeah.
the confusion which will arise is that you at times you will see 22.4 liter, at times you might see 22.7 liter, and that is what I wanted to
Mm-hmm.
clarify. Because if you
Okay.
look at your old text, if you look at your class 10th Dalal, again there might be, he might have done something else. But now what the definition that I'll be following is as per the class 11th NCERT textbook. Have you understood?
Yeah.
Just to add to more confusion, just to add to more confusion, there is something, they are saying that there is something called standard ambient temperature and pressure. Of course, when you look at the conditions, the conditions are approximately 25 degree Celsius and 1 bar. And now the molar volume becomes 24.7 liter per mole. Have you understood?
Yeah.
Now, what you should be aware is that when you see the molar volume written in different figures, you should be aware that what is the condition of temperature and pressure that they are taking. Does it make sense? And
Okay. Yeah.
you should be very well aware of the temperature and pressure that they are using. Are we clear till here?
Yeah.
And when we will be doing numericals from again, this guy is a private publisher.
Mm-hmm.
What you need to understand is that this definition that he is giving, 0 degrees Celsius and 1 atmosphere pressure, now you'll understand this is as per the old STP, and that is why the figure that he is giving is 22.4 liter. Is it making sense now?
Mm-hmm. Yeah.
So you should be, aware of all this. So uh, I've given the whatever gist that we have discussed now here. So 1 bar is 10 raised to 5 Pascal. 1 atmosphere is equal to the conversion between atmosphere and Pascal is written here. Then old STP is 22.4 liter, new STP is 22.7 liter. In this book, in the book that we are referring to now, he has taken a value of 22.4 liter per mole. Are we okay?
Yeah.
Because I don't want you to get confused. Because when we'll be doing the chapter 5 numericals or physics numericals, we should be aware what is the molar volume of a gas. Are we clear?
Yeah.
Uh, if you remember, this is PV is equal to nRT. Do you remember a bit of this? Have you ever
Yeah.
heard?
A little.
Yeah, yeah, absolutely, absolutely fine, absolutely fine. Because we will be doing this PV is equal to nRT again in class 11,
Mm-hmm.
chapter
Okay.
5. I'll just try to, I'll just spend 1 minute to tell you how the things become, why the volume differ. The volume differ because you have pressure,
Mm-hmm.
volume, and temperature. Now, depending upon the conditions of pressure and temperature, the volume would differ.
Mm.
Have you understood what I said?
Yeah.
Now, as per the conditions of pressure and temperature, this volume would differ. And that is why you see 22.4 liter, 22.7 liter. That is why you see various figures of volume because the pressure and the temperature they are changing. Is it making sense?
Yeah.
So don't worry, we'll be doing a lot of numericals. I just want you to be aware. If you are not aware today, then whenever we are doing the numericals and whenever you see various figures 22.4 liter or 24.7 liter,
Mm-hmm.
be aware कि भाई
Okay.
ये बात एक बार हुई है और कुछ ना कुछ गड़बड़ है.
Yeah.
That is
Mm.
all that I
Okay.
want you to be aware of. So right now, why we are worried about this is because we just want that when we are doing numericals, what we should understand is that 1 mole of gas would be equal to 22.4 liter. Are we clear about this?
Yeah.
So if I take 18 gram of water vapor, the 18 gram of water vapor would be equal to 22.4 liter. If I take CH4, if I take 16 gram of CH4, this
Mm-hmm.
is 1 mole. This is Avogadro number of molecules. And the volume of 16 gram of methane gas would be equal to 22.4 liter. Are we clear?
Yeah.
Now, with whatever gyan I have given you, you should be able to solve the numericals from example 34 to example 53. Is it okay?
Yeah.
And once we are through with this, then we'll go to the next topic, which is the percentage composition and molecular mass. Are we clear?
Okay. Yeah.
Now, in the NCRT book, if you refer to chapter 1 of NCRT book,
Mm-hmm.
this atomic mass, molecular mass, average atomic mass, formula mass, this is what we had discussed in the last lecture. And today we understood the concept of mole concept and molar masses. This is something, percent composition is something we'll be doing in the next lecture. Are we clear?
Yeah.